Hello, Mr. Ahmad. This is our final presentation about our last project regarding diffraction. This is our group. First, we are going to talk about the purpose of the experiment, determining the diameter of natural fiber by using the diffraction method, determining the various diameter of the fiber based on the diffraction pattern displayed on the layer. Now we have the basic theory. Diffraction is a phenomenon that occurs when waves encounter an obstacle or aperture and spread out or bend around it. It is, it is a characteristic property of waves and can be observed in various types of waves, including sound waves, light waves, and water waves. Huygens principle. Huygens principle explains the principles of diffraction. According to this principle, each point on a wavefront can be considered as a source of secondary wavelets that spread out in all directions. When these secondary wavelets encounter an obstacle or aperture, they interfere with each other, resulting in a diffraction pattern. Now, the advantages. Diffraction is used in X-ray crystallography to determine the structures of molecules and crystals. Diffraction could be also used in acoustics to control the propagation of sound waves and reduce noise in buildings and structures. Now we have limitation and disadvantages. Diffraction can limit the resolution of optical instruments such as telescopes and microscopes. Diffraction can cause interference effects that affect the quality of signals in communication systems. Huygens-Fresnel principle. The Huygens-Fresnel principle states that each point on a wavefront can be considered a source of secondary wavelets that spread out in all directions. Now we have the equation such as D equals N times lambda times L divided by A sin theta. Diffraction grating. A diffraction grating consists of closely spaced parallel lines that act as a series of parallel slits for the light to pass through. Light passing through the grating interferes constructively or destructively depending on the angle of diffraction. Now we have our analysis. The spacing between adjacent fringes is proportional to the wavelength, the distance between the grating and the screen, and the order of the fringe. By measuring the distance between adjacent fringes and knowing the other parameters in the equation, one can determine the wavelength of the incident light. This makes the diffraction grating a useful tool for analyzing the spectra of light sources such as stars and gases. Now we have our experimental materials, as you can see at the table. Now, the procedures of the experiment. Measurement setup, we have laser or light source, collimating lens, block paper screen, 3 types of fiber, 0.5 millimeters mechanical pencil lead. With each purpose of components, collimating lens ensures parallel light waves interact with the fiber, and screen captures the resulting diffraction pattern. Now, our procedures. We have followed 1 till 13 steps, as you can see in the video later on. After that, we have data processing. We have raw data collection. As you can see, we have 3 trials in the table. And we have average and approximate fiber weights from our experiment. Our analysis, establishing collaboration relationship, use references samples with known diameters. Analyze diffraction patterns from reference samples, derive collaboration curve or mathematical model. Fiber diameter measurement, recording diffraction patterns. Record diffraction patterns to 3 types of fiber using the measurement setup. Based on the data acquired from our experiment, we can input the measurement from the 3 separate leaves into the initial formula, which would produce this table, as you can see. And then our conclusion, the experiment aimed to calculate the diameter of natural fibers using Babinet's principle technique. Babinet's principle involved mathematical equations and experiment to determine the fiber diameter. The experiment examined the relationship between the distance from the center of the diffraction pattern to the first block and the distance from the fiber to the projection screen. Based on the experimental data, Increasing the distance between the fiber and the projection screen led to an increase in the distance between the center of diffraction pattern and the first dark band. This relationship can be analyzed, calculated using an equation where x is proportional to L. And that's it for our presentation. We hope you liked it, and please give our feedback.